And welcome to Technology Tap. I'm Professor J. Rod. In this episode, Understanding Network Services. Let's tap in. Welcome back to another episode of Technology Tap, the show where we keep tapping into technology and unpack the things that make our digital world run quietly, efficiently, and most of the time without you ever noticing. I'm your host, Professor J. Rod, and today we're diving into something that most people never even think about, but absolutely can't live without. That's network services. If the internet were a city, there will be street lights, the traffic cops, the water systems, the subway lines, all the infrastructure that keeps everything moving. You don't see them, you don't interact with them directly, but without them, chaos. And that's what today's episode is about. No reading slides, no robotic definitions, just conversation. You and me. So grab your cup of coffee, grab your notebook, and let's begin. Network host services, the services you never see, but you always use. Let me start with a visual. Imagine it's 8:03 a.m., an office in downtown Manhattan. Employees walking in with coffee, scanning their badges, logging into their PCs. Someone goes to print out a weekly report. Someone else pulls up the last quarter's financial spreadsheet from the shared drive. Another person opens the HR portal to check their benefits. Nobody thinks, which server is handling this? Nobody says, is it SMB? Is it Radius? Am I authenticating via LDAP? Nope, they just expect it to work. But behind the scenes, network services are firing like neurons in a human brain. Let's walk through them. File and print servers. I always start with this because it's the simplest to visualize. When you click on a folder on a shared drive and you're mapped to, let's say, a server, right? A file server, right? That's what you're tapping into. You're tapping into a file server. There's a machine, often a powerful one, that stores files centrally so that the users across the network can access them. And here is where the protocols come in. SMB, server message block. SMB is the king of Windows file sharing. Every time you map a network drive, every time you pull a Word document from the share, SMB is doing the work. And if you're in a mixed environment, Linux talking to Windows or vice versa, that's where Samba comes in. It's the glue. Now add printing to the mix. You send a print job, the server queues it, and then pushes it to the network printer. Simple, right? Until somebody prints a 200-page PDF and installs the print queue for the entire office. Then suddenly, everybody cares about the print server. I always joke, a print server only becomes famous when it breaks. So it's the port number for SMB is 445 for SMB. So you may need that for the CompTIA exam to know that number. And for Samba, it's still 445. It's the same thing. So it's 137 to 139 for NetBIOS, but that's an old one. We haven't used NetBIOS since the 1990s, so you're good with that. Then you got FTP, FTPS, and SFTP. Now, FTP, it's an old school plain text. Don't use it unless you're in a sandbox lab, port number 2021. FTPS is FTPS plus TLS encryption. That uses port number also 21. And SFTP, it's weird that they use the same port number. SFTP runs over SSH encrypted, it's secure, modern, and that port number is 22. If your job is to remote file uploads, website files, firmware updates, configuration backup, SFTP is what you want, period. Real world example, a small business web developer uploads updated HTML files to the hosting server every week using SFTP. Secure, encrypted, no passwords flying around in plain text. Database servers. Now picture Amazon or Netflix or even your college registration system. Every login, every product search, every streaming queue, they all come from the database server. Let me break it down super simple. You have your flat files, CSV files, Excel sheets, very basic. Then you have your relational database, SQL. Tables, rows, columns, highly organized. Example, MySQL, MariaDB, Microsoft SQL Server, Oracle. Then you have your non-relational, no SQL, think big data, massive, schemaless, perfect for logs, sensors, Internet of Things. Example, MongoDB or CouchDB. So here's an analogy. Our relational database is like a filing cabinet with perfectly labeled folders. No SQL is more like an inbox full of receipts. You dump everything in there and you organize it later. Real world scenario. A college stores students' registration info, names, grades, transcript in a relational database. But the millions of log entries tracking login events and security events, that goes into no SQL. Web servers. Let me ask you this. When you type www.google.com, what happens? Your browser sends an HTTPS request to a web server. The server responds with a web page. Simple, right? Except there are two ways to do it, right? There's port 80, which is HTTP, and there's port 443, which is HTTPS, is HTTP encrypted with TLS. This is where the certificates come in. You know that little lock icon next to a website, which I don't really see it anymore, but it used to be there. That's a certificate authority verifying the website's identity. And this started because Google, this is enforced by Google. If you don't have HTTPS on your page, it lowers your ranking. So if you're selling shoes online and your website is not HTTPS, nobody will ever find it because they bury you deep in the searches because you're not secure. They want everybody secure. All right, I once had a student who thought HTTPS meant the website was safe. I said no. It means the connection is encrypted. A scam site can still have HTTPS. And that changed how he viewed the web forever. Then you have mail servers and mailbox servers. Every time you send an email, you probably don't think about ports or protocol, but the server does. Sending email is SMTP, Single Mail Transport Protocol, port 25. That's the old one. We use now SMTPS, port 465 or 587. That's secure. That's just for sending emails. Receiving emails, POP3, Post Office Protocol, port 110 is the old, and 995 is the new one. Download and removes messages. This is the old way of doing email, where it downloads from the server to the device that you have, and it's kept on the device. It's not kept on the server anymore, right? It removes the message from the server, so it just downloads. And then IMAP, port 143, a new one is 993, syncs across devices. This is what we normally use now for like Google and Outlook, right? The email gets stored on their server, and we can look at on our phone and look at it, on our computers and look at it, on our laptops and look at it. The email's still there. If you check your email on both your phone and laptop and everything matches perfectly, that's IMAP. Authentication, LDAP, Radius, TACDIS Plus. This is where things get spicy. Every time a student logs into their college, the username and passwords get sent to a Radius server. Every time a company employee logs into a domain computer, that authentication checks LDAP. You have your AAA, authentication, authorization, and accounting. This is the holy trinity. It answers, who are you, What are you allowed to do, and what did you do for logging purposes? Radius is used for Wi-Fi logins, centralized authentication. TACAX Plus is used for device management, routers, switches, and firewalls. Example is a network admin logs into a Cisco switch. TACAX logs every command he types. Accountability is on point. Next, we go to internet and embedded appliances. When devices start thinking for themselves and start talking behind your back. All right. Take a breath, sip that coffee, because now we are going to walk through a live IT environment. We're leaving the comfort of the classic file print web server world and stepping into the front lines of modern networking. With proxy servers, spam gateways, unified threat management, load balancers, legacy systems, embedded systems, and ICS, SCADA, IoT, and smart devices. This is where traditional IT meets the internet, meets automation, meets security, meets some occasional chaos. Let's jump in. Proxy server, the middleman with all the power. Let me take you back to one of my early campus IT consulting days. There was a high school that called me because students were getting around the contact filters with, you guessed it, VPN apps. The school had a firewall, but they didn't use a proxy server. Walking into the building felt like walking into a scene from a spy movie. Kids whispering about IP address, Chrome extensions, secret URLs. Every student was a James Bond villain in training. A proxy server will fix everything. So what is proxy? Imagine you're at a restaurant. Instead of ordering directly from the kitchen, you give the order to the waiter. The waiter filters, approves, and handles your request. A proxy server is the waiter. When you visit a website, your request goes to a proxy. The proxy decides if it's allowed. Then the proxy fetches the site and sends it back. What are the real-world functions of this? Content filtering, blocking YouTube, social media, adult content. Caching, saving bandwidth by storing common pages. Traffic logging, admins can see who visits what. And masking internal IP for privacy. Another story. I once helped a business that was choking on bandwidth because everybody streamed March Madness games at work. Once a proxy was installed, boom, they cut the bandwidth usage in half. Employees were mad. The owner was thrilled. Balance in the universe was restored. Next, we're going to talk about spam, gateways, and UTM, your email's bouncer and your network's bodyguard. Email is the wild, wild west of the internet. If the internet were a country, email will be the border crossing where you must show your passport, and every scammer and bot tries to sneak in through with a fake ID. Sounds very topical. Spam gateway, this is a system that checks incoming mail before it even reaches your inbox. It's looking at sender reputation, IP address, known malware signatures, keywords, attachments, known phishing domains, and something called SPF, DKM, and DMARC mark. Not the D mark that's in your ISP equipment, not that. SPF verifies the sending server is allowed. DKIM, digital signature to ensure message integrity, and DMARC tells server what to do if the message fails checks. Think of it as SPF being, are you on the guest list, and DKIM being, is your ID legit, and DMARC, if your ID fails, kick them out or send them to spam. Unified threat management. Now this one's a beast. A UTM is basically the Swiss Army knife of security appliance. It does firewall, antivirus, anti-malware, IDS, IPS, web filtering, VPN, sandboxing, all bundled into one device. Real world story. There was a dentist office I visited once, small, maybe 10, 12 desktops. They had a basic router, no firewall, no antivirus, Windows XP running on one machine. Yes, Windows XP. Doctors checking Gmail on the state network as patients' medical records. A single UTM box fixed almost everything. When I installed it, the owner looked at me and said, I didn't know we needed that. And I said, you didn't know you needed it through sheer luck alone. Load balancers, because one server is never enough. Ever wonder how Amazon handles millions of people shopping at the same time? Or how Netflix streams to hundreds of thousands of users simultaneously without breaking? Or how your college portal crashes only during registration week because they don't have one? This is where load balancers come in. A load balancer sits in front of multiple servers and spreads the work evenly. Think of it as a toll booth. One open lane equals a massive line. 10 open lanes equals smooth traffic. That's load balancing. When a web server gets overloaded, the load balancer shifts traffic to a less busy server. When a server fails, the load balancer removes it from the pool automatically. Load balancers can even detect slow performance before the users notice. A practical example. Imagine you're running a restaurant. There's one chef in the kitchen. Orders pile up. Chaos. Now imagine you have 5 chefs and a head chef deciding who handles which order. The head chef is your load balancer. Every semester when students try to visit Blackboard or Brightspace at the same time, the system slows down or crashes because the servers are overloaded. If the college students had a better load balancing plan, students would complain a lot less. Legacy systems, the ancient creatures still alive in modern networks. Legacy systems are the dinosaur of IT. And here's one thing. Dinosaurs are still alive in some networks. End of life. The manufacturer no longer sells or updates the system. End of service life. No more support, no more patches, no security updates. You're on your own. These systems can be old medical machines, manufacturing equipment, point of sale systems, old government systems, custom built software no one knows how to maintain. I once walked into an office and still ran their business on an old Windows XP machine. They said, "We can't replace it because the software it runs doesn't exist anymore." The machine was their entire operation. No backup, no imaging, just pure hope. If the machine failed, that was the end of the business. This is why legacy systems matter. They're risky, but people keep them alive because replacing them is expensive, complicated, or practically impossible. Embedded systems and ICS. Computers that don't look like computers. Now we enter the industrial world. Embedded systems. These are computers built into the device to perform a very specific functions. Example, smart thermostat, routers, microwave controllers, medical machines, car infotainment systems. They're not meant for browsing the internet or running Word. They're built for one job and they do that job extremely well. ICS, industrial control systems. These run factories, power plants, HVAC, elevator controls, big, heavy, serious systems. If a regular PC fails, annoying. If an ICS fails, worse things happen. Then we have SCADA, the nervous systems of modern infrastructure. SCADA stands for Supervisory Control and Data Acquisition. It is a system that monitors and controls entire industrial environments. Power grids, water treatment plants, subway systems, gas pipelines. These systems are often distributed across wide geographical areas and SCADA ties them together. Real world example. When you turn on your faucet, there's a water treatment facility using SCADA to monitor the pressure, the flow rate, the chemical balance, the pump performance. It's the quiet hero. And if SCADA goes down, you don't want to know what happens. It's going to be miserable. That Die Hard 4 is kind of like talks about a lot of that movie Die Hard 4. All right. Troubleshooting networks. When things break, and they always do, here's what you do next. Okay. This is where IT becomes real because theory is beautiful, diagrams are clean, and slides are perfect, but troubleshooting is messy. It's part of IT where you're on the floor behind a desk, someone is breathing over your shoulder, someone else is saying, it worked yesterday, and your coffee's getting cold. Welcome to Help Desk Life. Let's go step by step. Troubleshooting wired connection. If it has a cable, that cable will betray you eventually. Wired issues are the foundation of troubleshooting. No matter how advanced your environment is, at some point you will crawl under your desk. That is true. Let me give you a real story. I was once called to troubleshoot an office PC. Every 10 minutes, connection drops, then reconnects, then drops again. Classic port flapping. I checked IP config, switch port, NIC drivers, patch panel, everything looked normal. Then I saw it. The internet was pinched under the wheel of the person's chair. Every time he rolled back, signal loss. Every time he rolled forward, connection restored. That was it. A $5 cable cost 2 weeks of help desk tickets. Common wired issues: loose connection, damaged cable, bent cable with broken copper pairs, bad NIC, speed duplex mismatch, incorrect VLAN assignments, port security blocking the device, patch panel miswiring. Here's a tip. Always inspect the physical layer first. 50% of the wired issues are physical. Troubleshooting network speed. Slow internet is the fastest way to make people hate IT. When a user says the network is slow, this can mean 20 different things. A student once told me, "Professor, the Wi-Fi is slow. I can't upload the assignment." You know what the problem was? They were loading a 2 gig video over 2.4 gigahertz Wi-Fi from the basement of their house, though there were cement walls while they were on Zoom. Even NASA can help you with that one. Real cause of slow network speeds: port misconfiguration. Switch port is set to 100 megabytes, but the NIC supports 1 gigabyte. Bad cabling, Cat5 instead of Cat6, or damaged copper, or cable runs that exceed 100 meters. Interference, fluorescent lights, microwave, old power cables, even fish tanks interfere. Malware, a compromised PC sending backward traffic can slow everything. Saturations, too many devices streaming, or one user hogging bandwidth. Next, troubleshooting wireless issues. Wi-Fi, the thing everyone uses but nobody understands. Wireless issues are tricky because radio waves don't obey workplace rules. They go through walls, around corners, into ceilings, into stairwells, or just disappear. I was once on the 13th floor of a building, and I can get the Wi-Fi from across the street from the deli. He had it unopened. 4 years. 4 years he had it open. And we used to watch Netflix. That's when Netflix went on streaming. A company once had a Wi-Fi ghost zone. Every afternoon, one section of the office lost connection. Same time every day, like clockwork. Was it cyber attacks, sunspots, ghosts, chaos theory? Nope. At 2 p.m., an employee on break plugged in their own portable microwave and heated up a bowl of leftover spaghettis. 2.4 gigahertz interference. Microwave on, Wi-Fi dead. Microwave off, Wi-Fi restored. Case closed. Common wireless problems: poor signal, users too far from the access point, band selection, a device on 2.4, but the access point is set to 5 gigahertz only, no connection. Mismatch Wi-Fi standards, user's laptop only supports 802.11n, but the network forces 802.11 AC. Channel overlap, specifically with 2.4. Device interference, microwaves, cordless phones, baby monitors, smart TVs. Incorrect security settings. AP uses WPA3, but device can only authenticate via WPA2. Roaming aggression, device refused to switch to better APs. Troubleshooting VoIP, voice over IP. Voice over IP is amazing until it glitches. VoIP has 3 enemies: latency, jitter, and packet loss. Latency is delay in audio. Jitter is variation in delay, causes choppy audio. Packet loss, audio drops. I heard a story once about a guy working at a call center once when the agent complained, "I hear the customer fine, but they hear me underwater." Turns out the office next door installed a massive new network printer on the same switch as the call center's VoIP phones. Every time somebody printed, it consumed bandwidth and caused jitter. Solution: move the printer to a separate VLAN and prioritize VoIP traffic with quality of service. Clear call instantly. Troubleshooting limited connectivity. The dreaded connected no internet message. This is an iconic Windows message that haunts people everywhere. Common causes: wrong IP, wrong subnet mask, wrong gateway, DNS not responding, DHCP scope exhausted, duplicate IP, block port. Quick story. An HR manager plugged in a personal printer at home. brought it to the office, plugged it in again. And it happened to be configured with a static IP that matched somebody else's IP at the office. Guess who lost internet every time the printer was powered on? Exactly. All right, wrap up. The invisible world becomes visible. We covered host services, web mail authentication, proxy and filtering, Internet of Things and SCADA, load balancing, wired and wireless troubleshooting, VoIP, and VLANs. Now, on to the questions. Everybody's favorite topic or section of the podcast. All right, I'll read the question, give you the choices, read it back. You give me the answer. Question 1. A user reports slow internet during lunchtime. The most likely cause is A, incorrect DNS server, B, network saturation, C, wrong subnet mask, D, DHCP lease expiration. Again, a user reports slow internet only during lunchtime. The most likely cause is A, incorrect DNS server, B, network saturation, C, wrong subnet mask, or D, DHCP lease expiration. It's not giving you a lot. This question doesn't give you a lot to go on. But I'll give you 5 seconds. 5, 4, 3, 2, 1. The answer is B, network saturation. Anybody at lunchtime is using the internet to watch something, right? Maybe la casa de lo, you know what. 2, a wireless user loses connection every time they walk into a conference room. Signal immediately returns when they leave. The most likely problem is A, DHCP failure, B, drop due to interference, C, duplicate IP, or D, incorrect VLAN. A wireless user loses connection every time they walk into a conference room. Signal immediately returns when they leave. The most likely problem is A, DHCP failure, B, drop due to interference, C, duplicate IP, or D, incorrect VLAN. I'll give you 5 seconds. 5, 4, 3, 2, 1. And the answer is B, drop due to interference. There's something in the room that's causing it to interfere. All right, hopefully you're 2 for 2. Next, a VoIP system has choppy audio and robotic voices. Which issue is it most likely? A, low RSSI, B, high jitter, C, wrong DNS, or D, incorrect gateway. I'll read it again. A VoIP system has a choppy audio and robotic voices. Which issue is most likely? A, low RSSI, B, high jitter, C, wrong DNS, or D, incorrect gateway. I'll give you 5 seconds. 5, 4, 3, 2, 1. And the correct answer is B, high jitter. All right, last one. Let's go for 4 for 4. A PC plugged into a switch port shows connected, no internet. Other PCs work fine. What should the technician check first? A, monitor resolution, B, duplicate settings, C, incorrect IP, or D, the keyboard. A PC plugged into a switch port shows connected, no internet. Other PCs work fine. What should the technician check first? A, monitor resolution, B, duplicate settings, C, incorrect IP address, or D, keyboard. I'll give you 5 seconds. 5, 4, 3, 2, 1. And the answer is C, incorrect IP address. All right, that's going to wrap it up for us today. Thank you for listening to the episode on network services, and we hope you learned something. And as always, keep tapping into technology, and we'll see you next time. This has been a presentation of Little Cha Cha Productions, art by Sarah, music by Joe Kim. We're now part of the Pod Match Network. You can follow me at TikTok at Professor J Rod, that's JROD, or you can email me at ProfessorJRod, JROD, @gmail.com.